Hello there. Can the people in the back row hear me? Please wave your hand if you can hear me. Oh, you're so welcoming. Thank you.
We should do like this. Before I present to the next topic we'll be discussing about, I just want to remind you that we have a sprint and bugs that we can fix really easy. You should go to one of the links mentioned in the tables and check the good first bugs that we have listed there. It will be an easy way for you to start contributing to Mozilla. We will be rewarding you with t-shirts for them. Ping me if you fixed the one or go to the Mozilla booth in the building K. So coming up next, it's a presentation about Servo and You. And it's really nice to present you, the speaker, because I felt he's more like a hacker in music domain than in us. So he started contributing to Mozilla in 2009 after he read a blog post about electrolysis. And since then he did a lot of things, including many easy tools for new people to join and contribute to Mozilla. Some of them are like, what can I do for Mozilla, What's a Hoy, or even Fox in a Box. He's, like I mentioned, into a lot of music stuff, and I have to read them because it's a lot for me. And here I go. He is the singer of Waterboys band, plays the keyboard drum for the Waterloo Orchestra, part of the Rupert St. Louis band also, and of course plays the guitar when he has some free time. Is that even possible? Please welcome Josh.
Thank you. All right, I'm going to zip through. What is Servo? Servo is a brand new web browser engine. So it's not the actual browser that we care about, it's the thing that renders the web pages for you. And it's something that we're building from the ground up with the knowledge that we've gained after building Firefox for the past 10, 15 years. We think that we can do better if we start from a clean slate. Additionally, we are writing it in the programming language called Rust, which is a language that we are also creating from scratch because C++ is just not good enough when it comes to browsers. If you'd like to learn more about precisely what that means, what Rust is, how that affects Servo, I suggest looking at the talk that was given by my colleague Jack Moffitt at LCA 2015. But we'll just move right on ahead and assume that you want to learn how to contribute to Servo. Now, why would you want to contribute to Servo? Well, we all know that web browsers are big and complex and challenging. But it's a good kind of challenge, I find. It's a really interesting environment, and there's a lot of really interesting constraints around security and performance that you just don't get in other domains. So if you want to have a fun time challenging yourself and expanding your skills, Servo is great for that. Additionally, we just released the Rust 1.0 alpha. So that is the first version of Rust that we feel is a good snapshot of what the language is going to be like after the 1.0 release, which is going to be pretty soon, in the next couple months. And that means that the language is settling down, and there's a lot of interest in starting to write Rust code for the first time. However, oftentimes people say, well, Rust sounds cool, but I don't know what to use it for. So Servo is a great place to try your hand writing actual Rust code that will make a difference, and write it in a real-world setting, too. So you can make a huge impact, because there are a lot of things that Servo is missing right now, and we are counting on other people to help us out. So let's talk about what Servo does right now. It is a really good Wikipedia browser. We have optimized it for that case. We actually have a member of the team who uses it primarily for all of his Wikipedia browsing. We have some forum support, so you can submit text. You can use checkboxes and things. If you want to read blog posts, Servo's great for that. We just got basic Canvas support recently, and that was actually contributed by a student at a university in Hungary. We support 100% of CSS1 properties and 75% of CSS2 properties. And when I say support, what I mean is we parse them, and there's at least like one keyword or one property in there which will cause something to change on the screen if you use it. It is expanding. What this means is that we can do things like get SVG support for Servo very easily by using the Canvas support and just injecting a polyfill that will parse any SVG in a page and will then draw that onto a canvas. So we have that working in a branch right now, and that's using the excellent CanVG library. Other things that work right now. For a Summer of Code project, we had a student write an implementation of XML HTTP request. We have students from North Carolina State University who, for a class project, submitted an implementation of session storage. We have workers working We have HTML element.style. You can modify properties, you can retrieve properties. We also have developer tool integration with Firefox, because Firefox supports remote developer tools, and we can do that. We have it working on Android, on OS X, on Linux, for 32 and 64-bit operating systems. And another student from the university in Hungary has also contributed AR64 support. So let's take a brief look at what it actually does right now. So what I'm going to be showing you is, whoa, no, not that. Where did Xcode go? Here we go. So we have written a little small browser UI in Cocoa, which gives you things that look like tabs and back and forward, and gives you a URL bar, which usually loads things if it's on the network. I can't even tell if I'm connected. Oh, nope. All right, that's not going to work. All right, no demo. Oh, there it is. It loaded. So, I was bragging about our Wikipedia support before, so let's put that to the test. Wiki/Rust programming language. Let's see what Wikipedia says about the Rust language. So the thing to note here is not how slow it is loading things, because that's just a really terrible networking code. That's not actually interesting. What you will see is that we have a really, really slick scrolling, and you can click links. And what more do you need in a browser, really? And they load. You can improve this article if you want. Now, the other cool thing is that we have a really nice backwards and forwards cache, so it just zips right through it. So there's parts of Servo which are really cool right now. So the new tab button doesn't actually work, but in the GTK one, it does. So enough of that. We're not here for shiny things. We're here for work. All right, so what are we missing? Most things, actually. A lot of things. Most of the things on the interesting website to care about. Iframes, document load events, those are harder than you might think. Inner HTML, who uses that? But like really, these are just, like, a lot of these things are just work that needs to be done rather than fundamental problems with the architecture. There's just, as I said, a lot of work. The web is really big. And there are many things which could be done by anyone willing to sit down and read some specs or talk with us and wants to try their hand at Rust code. And some of these things we're still working with students to work on these things. Others, we have a large set of volunteers who are contributing right now. And these things are just, they're getting done slowly. So the problem is that as cool as demos like I just showed you are, it's hard to actually draw comparisons that are realistic between Servo and Firefox right now. Because there are so many things we don't implement, it's hard to say whether that's actually influencing like the timings we get when we're rendering pages. So in order to actually demonstrate that our ideas are as realistic as we think they are, we need to be able to show actual feature parity with real web browsers when comparing sites. So, as I showed, many things need to be accomplished. And the good thing is that we, as a team, are really good about taking all of that work and splitting it up into bite-sized pieces that anyone who is motivated could attack. Now, maybe you're looking at this and going, well, web browser design, you just told me about how complicated it is, and there's so many things. Maybe that's not for me. But I'm going to tell you, we have a really large crowd of volunteers, and in the past month alone, we had 11 new contributors show up, and a lot of their first pull requests on GitHub contained the phrase, now, this is my first Rust code I've ever written, so I'm probably doing everything wrong. I'll tell you, they weren't. They're really good. It's a language that you can pick up. There's lots of people, there are students from North Carolina State who, as part of a class project for credit, the prof came to us and said, could you give us some projects to work on? And we said, sure, how about these ones? And they submitted their code, and they got credit for it, and it was their very first time using Rust. And it's not like they're programming language polyglots or anything. These are people who often only had some experience using like Java or Python before they came to it. So there's a pretty good track record for getting involved for the first time. So how does it start? You clone the GitHub repository. That won't take too long. There's a lot of code in there, but it's just code. So then you'll install the prerequisites, which we have listed for a bunch of different operating systems in the README, which is very handy. And then you'll use the command mock build. And what that means is we have this tool called mock. It's actually a framework written in Python, which allows us to create development tools really easily, which are very helpful. And so that's what we've built our build system on top of. So anytime you want to compile Servo, you'll just run this mock build tool, and it'll do everything that needs doing. So the very first time you build, it'll download the Rust compiler. It'll download the package manager. It'll download all of the 25 or 30 dependencies, including Skia, which is whatever. It's huge, and I'm really sorry about that. It's a long download. So you'll need to wait for the first time. But after that, most of the builds will probably take anywhere from 3 to 10 minutes, depending on what you change and how good your hardware is. I think a MacBook from last year, that takes 2 to 3 minutes to compile most changes, I think. So what is it you could actually work on? I mean, you could just go back to that list that I showed you of all those really cool things that don't work yet. But we also make suggestions, and we have the issue tracker, and we label things as being easy or less easy to help people get started. So the easy ones, obviously, they're going to be ones which we've written a pretty good description of the changes we expect to be made and where to find references for the code you'll be looking at and the spec that you'll be referring to. And they're usually a really isolated piece of work that won't take too long, we expect. And then if you're up for more of a challenge, we have the less easy category, and those will be perhaps more interesting, but also accordingly more complicated. And to show you what I mean, these are examples. So this is one that was filed by one of our contributors recently. As I said, there's this easy tag, and so he links to the spec you'll need to read, it links to the code you'll need to be modifying, and it links to the test you'll need to run, which will demonstrate that this change works. So that's great. And within 2 weeks, I think that was picked up by someone for the very first time. I've never seen them before, and they submitted a pull request, so that's pretty cool. Whereas for less easy, it's still about implementing missing features, but even still, there's still a decent description of the sort of steps you'll want to go through in order to solve it. So, lots of information. We absolutely love helping people get started for the first time. So, let's talk about the source code. The most exciting bits of Servo live in 5 directories, and they're all within the components directory. There's compositing, and that's your input events, that's your event loop, that's your window management, and the actual compositor, of course. Then you've got GFX, which is the graphic stack, and that's the thing that actually paints the images to the screen, or paints everything you need to see. It does parallel painting, it does CPU or GPU painting, there's font stuff, there's text stuff, whatever. You've got your layout code, and that's the stuff which takes your actual document model and figures out where your boxes should be, how big they should be, what colors they should have, what shadows there should be. It applies the styling and just flattens it into something that will then be painted. You've got your script directory, and that's everything that's related to JavaScript execution. It's related to actually taking the input events from the compositor and then actually dispatching them as DOM events to the page. It does things like actually implementing the DOM specification. So there's a lot of code in there. And then finally, you have your style directory. And that's everything for integrating with the CSS parser and creating the data types that'll be filled up by layout while figuring out the styling of all the elements. So often we find that an easy way to get started contributing to Servo is through implementing DOM features. So you'll find everything you need in the component script DOM directory. And these actually correspond directly to elements that are in the specifications. So if you're implementing something related to HTML element, then that will be found in the HTML element.rs file. Furthermore, the spec also defines interfaces using a language called WebIDL. So we actually are able to directly copy and paste those into our source tree, and then those turn into generated Rust code, which actually hooks up the Rust code or the Rust implementation to the JavaScript objects that web pages interact with. And what that means is that you also get a trait, which is a little bit like a Java interface or a C++ abstract class. which then lists all the methods that you will need to implement in Rust code in order to have a full implementation according to the interface. So let's take a look at what that means in practice. So here is one of these interfaces. For the document object, you might recognize it. You've got these attributes, and that refers to the properties on JavaScript objects, where you can do things like document.domain equals foo.com. Whereas a read-only attribute is only a getter. You can't set it. And then you also have methods. You've got a get element by name, where you pass in a DOM string and you get back a node list. And these all correspond to Rust types, and they all show up as code that you need to implement. And so what that means in practice is that if we search for document methods, how big is that? Should I make it bigger? Is that good? So document methods is the generated trait. So here we implement this trait for the document object. And so if we look at this, there is a corresponding last modified, I believe. So last modified is a read-only attribute. So it's only a getter. And so that corresponds with this method here, which is last modified. It returns a DOM string. And here's the code that says, if I don't have a last modified property internally already, just take the current time and format it in the way that we expect. So it's all quite simple. And we also have links to the spec if you need to refer to it at any time. So let's do something fun. Let's implement document.cookie right now. So what this means is we're going to copy an attribute from the spec into our local web IDL. Then we're going to implement that in the Rust code. Then we'll test the result because we have some built-in test files that we use already. And we'll make sure that it actually passes. So let's start. Let's look at the spec. In the resource metadata management, there is document.cookie. Now, that is in the IDL up here, attribute DOM string cookie. So let's look at document.webIDL. We'll just throw it in here. Very easy. Then we will go back to our implementation. Now, what you could do right now is you could compile it and Rust would complain that you're missing a method, but I know what that should be. So I'm going to do this. Yep. We'll also need to mark this as throws because it can throw errors. We'll go set cookie. Yes, it doesn't return anything. Or, no, sorry, it does. Error result. So, we return OK values by default. That's very simple. Now, I'm going to get my crib notes because it turns out it is hard to live code when you are in front of a large audience. So what did I write down here? So first, the spec says that on getting, if it is blah, 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 you must return empty string. Otherwise, the origin is not that. All right, let's implement that first. Let's figure out if the origin is a special tuple type. So let's make a function down here, is scheme host port tuple. And we'll take a URL. Nope, I forgot what that was. Host ISM port or default. All right, so we're just checking whether it has a host and a port. Then we'll go, if not, is scheme, let URL equal self.url. We'll copy that to the other one too. Then let page equal, well, window equals self.window.root. So we'll take the window object, we will get the page from it, and then we'll go page.resource task, because we have this API magically set up, which is get cookies for URL, and we'll give it a URL, and let's see. Oh, right, we'll need a channel too. Oh, and then non-HTTP. This is basically just implementing exactly what the spec says. Oop. Okay, rx dot. Oop. Okay, now go. If let's, nope, we'll do this the easy way. Unwrap or to owned. All right, so basically we're saying, give me the cookies for this URL, and then I will return the cookies that I've been given. So, then for setting cookies, we also have a similar API we can use, which looks like set cookies for URL. And that should be enough. So I'll add my imports at the top. All right, what I'll do actually is get checkout. Now, I'll build my changes that I just made. So, while we're waiting, so we just implemented document.cookie. You'll have to trust me on that. But if you wanted to get more information, then you can go to our documentation site. You can go to our IRC server. We have lots of people willing to help. You can go to the mailing list. You can go to the discussion forum. And yeah, that basically covers it. It's now your turn to help with Servo. You can do it. I believe in you. You can find the slides at the link on the screen. Please come talk to me afterwards if this interests you. I'd love to help.
Any questions?
See a question? The question was, what are the hardest things that we haven't solved in Servo? Let's see. Hardest thing would be some of the new CSS3 layout changes. Things like multi-column layouts and flexbox and pagination are things which we're not certain how they will fit into our parallel layout architecture yet. Other questions?
Where's my job?
Yes. I did not catch that. Let me come closer. The question is, do we use a scene graph in the layout engine? And are there plans to? And the answer is, I don't believe so, on either count. I'm not certain whether that's a common practice these days, or state of the art. All right, that looks like that covers it. Thank you very much.